Hi friends, very good morning. Today we are discussing how a generator works. What are the principles behind it? Okay, so shall we start? Yes. So this is the structure of an electric motor. It contains an armature coil in between two magnetic poles, north and south. Okay, then Then what? This armature coil, that is this structure ABCD, it is connected to two brushes, one this, two brushes, then two rings, that is split rings, and we have a galvanometer here. Okay, for what we are using galvanometer? We use galvanometer to inspect the presence of current. Okay, then now we can go deep into this working of this generator. So here this rings as well as spring as well as this brushes, it is connected, especially this split rings, it is connected to ensure this armature is free to rotate. Okay, it has the freedom to rotate, it's not fixed, it is free to rotate. Okay, so the split rings, it is used to ensure the freedom of rotation of this armature coil. Then we know that in between this north and south pole, we have magnetic field lines originating from north and ending at south. Okay, then actually what happens in a generator? What's really happening there? We are providing what? We are providing mechanical energy, and as a result, we get electrical energy, that is electrical energy, that is electricity that is induced, or electrical energy is generated in a generator. That's why it's named so as generator. Okay, so input is mechanical energy and the output, that is electrical energy. So here, when we are looking at this structure of this generator, okay, so we can observe that what we are actually doing, we are, yes, here we have an armature coil. Okay, this is north and south poles. Okay, north pole is here, south pole is here, and in between there's an armature coil which is attached to what? Split rings. And here a galvanometer, it is connected to detect the presence of current. And what we are doing is, we are providing mechanical energy to this armature coil so that it gets rotated. Already we know it has the freedom to rotate. That is, split rings are connected to it so that it has the freedom. This armature coil, it has the freedom to rotate. So we know there is magnetic field lines are there in between this north and south poles, fixed permanent magnets. Okay, so when we are rotating armature in that space, what happens really? What it causes? Suppose when we are rotating it, these field lines are here. These field lines are present here. Okay, so when we rotate this armature, it's cutting what? It's cutting that field lines. Okay, so the magnetic flux, the totality of this field lines, magnetic field lines, we call it as flux, magnetic flux. So when we are applying a force to rotate this, when we are providing mechanical energy to rotate this armature coil, we are actually cutting this flux. Okay, and when we are cutting this flux, we can observe what? This galvanometer needle that is deflected, indicating the presence or generation of current. Okay, Now we can move to that picture again. So this is that picture. Okay, we can observe it. So when we are rotating, we know that here we have what? Field lines. Here we have field lines in between, and when we are rotating it, this in this galvanometer, this what happens? In this galvanometer, this get generated. It's current, it's get generated here. Okay, in this circuit. Okay, so this is represented here. These are field lines, and this armature coil, which is here, we are rotating it. When we are rotating it, the flux lines link with this magnetic field or link with this permanent magnets, north and south pole. That is what happens. The flux link to that permanent magnet, it's get cut, and as a result current is induced, and so what happens, this galvanometer needle deflects, indicating the induction or generation of the current. Okay, so in the case of electric motor, we know that electric motor, in that case, the electrical energy we provide electrical energy. In the case of electric motor that we had discussed in the last class, if it is electric motor, then we will provide electrical energy. Okay, we will provide electrical energy, and what we get? Mechanical energy. So electrical energy is the input, and the mechanical energy is the output. Okay, in the case of generator, what we are doing? We are providing this mechanical energy. So here the input is what? Mechanical energy is the input, and what is the output here? The output is electrical energy. Why so? Yes, already we explained. Here what we are providing? We are rotating. Okay, we are rotating. That means when we are rotating this armature coil, that is, we are providing this, we are rotating means we are providing mechanical energy. So mechanical energy that we are providing. Okay, and so at last what is generated? This current is generated, electrical energy is generated here. Okay, so providing mechanical energy and electrical energy that is generated. So in the generator, the conversion of mechanical energy to electrical energy happens. The input is mechanical energy and the output is electrical energy. So in the case of electric motor, we have what? We have this Fleming's left hand rule. Fleming's left hand rule that we have in the case of what? Electric motor, that we already explained. Okay, in the case of electric motor, we have this Fleming's left hand rule to explain the direction, to give us the direction of this current. That is current. They are current in the electric motor. We are providing electrical energy. So the direction of this current, then magnetic field, then force. So it is given in this last class. The details about it, electric motor. And in the case of generator, what we have is Fleming's right hand rule. Fleming's right hand rule that we have. Right hand rule. Okay. So what is this Fleming's right hand rule? It gives the direction of the current that is induced, the magnetic field or the flux that is cut, the magnetic field, the direction of the magnetic field it give, the induced current it will give, the direction of it, and as well as the direction of the force that we are applying. Okay, so here we are holding our, this is Fleming's right hand rule, right? So we are holding our right hand, thumb, then forefinger and the middle finger in mutually perpendicular way. Okay, they are mutually perpendicular. This is your forefinger, this is your middle finger, and this is the thumb. Okay, so the direction of the forefinger represent the direction of the magnetic field, and the direction of the thumb represent the direction of the force that we are applying, the mechanical energy that we are providing in this direction. So the force that we are providing in this direction, then the current get induced in this direction. So they are mutually perpendicular. Okay, so Fleming's right hand rule gives the direction of what? Gives the direction of this induced current, magnetic field, and force in the case of generator. Okay, so that's all about the working of generator. So it's in the case of it's just reverse to that of electric motor. In the case of electric motor, what we are providing, just a comparison we can have. In the case of electric motor, we are providing electrical energy and we are getting mechanical energy. And the case of generator, reverse that. That is, we are providing mechanical energy and what we are getting is electrical energy. Electrical energy is generated. Then in the case of motor, it is the motor principle is behind it, and and the direction of this force generator, current and magnetic field is governed by Fleming's left hand rule. And here the direction of the force, then magnetic field, and the induced EMF, that is governed by Fleming's right hand rule. Okay, so let us consolidate. Yes, what are the parts of a electric generator? Okay, so what are these parts? It has a magnetic permanent magnet. Okay, in between a permanent magnet, what we are doing, we are placing an armature coil. This is armature coil. Okay, this type of coil, that is armature coil, that is simply a coil in of this shape, conductor of this shape, winded by electric wire. Okay, so then we are rotating this armature coil. So when we rotate it, what happens? This field lines between this permanent magnets, okay, it gets cut, and as a result there's a change in flux, and this change in flux leads to what? Change in flux leads to the generation of current in the circuit. Okay, circuit here, it is detected by what? Detected by the galvanometer. Okay, yes, so that's all about this electric generator. So in the coming class, we will have a deep analysis on this motor, electric motor, and electric generator, a comparative study, so that it gets more and more thorough for you. And this video, it's designed for 10th NCRT students. 10th NCRT students. It's based on their syllabus. So it will be really useful for you. So if you follow these classes in Ignite science classes, so if you really like this videos, classes that we are uh, uploading, please subscribe to this channel and mark your attendance by pressing the like button. Thank you so much. So we can meet in the next class with a different topic, uh, with different ideas. Okay.